Hello, everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to talk to you about how to name ionic compounds. Basically, how do you go from the formula to the name? So let's get into this. So, first thing you need to know is how to name your monoatomic ions. You need to know how to name the cations and your anions. So if you don't know how to do that, then go back to my other video where I talk about naming monoatomic cations and anions before watching this video. Uh, so let's get into the compounds here. So the first category that I'm going to talk about is your binary ionic compounds. Those are going to be the compounds that only have two atoms in their formula, or I should say, two elements in their formula. So they're going to have a cation element and a anion element, a positive element and a negative ion, right? So they're going to have two different ions, positive and negative, in their compound. We call those binary because of two elements. Okay, so the way you name ionic compounds, and this goes for binary as well as your elements or your compounds that have polyatomic ions in it. The way that you name any ionic compound is basically you're going to take the name of the cation, add it to the name of the anion, put it together, you get the name of your compound. It's that simple. I kid you not, that's as simple as it is. So you need to know the names of your ions. So the monoatomic ions as well as the polyatomic ions. Because if you know the names, you just put those names together and you've got the name of your compound. So let's go ahead and look at our binary ionic compounds first. So here we have NAF. That's the formula for this compound here, NAF. So you need to know what the name of the cation and the anion. Remember that the cation is always written first, the positive ion is first, negative ion is second. So you got to know how to name your negative and your positive ions. Remember that the positive ion name is always the name of the element. So we have sodium. The second ion is always the negative ion. And remember, the negative ion is named by the fact that you are going to take the root, drop the ending of the name of the element, and add IDE. And then that's the name of that ion. So Na is sodium. So that becomes the first name because that's the sodium ion. F minus, fluorine, drop the ending, add IDE, that's fluoride, and you add fluoride. So sodium fluoride is the name of this substance. So literally, you're taking the name of the first ion, sodium, taking the name of the second ion, fluoride, putting it together, sodium fluoride. It's that easy. Next, we have Mg. That's our positive ion, magnesium. So the name of the ion, Mg, is magnesium, Mg2 plus. So magnesium is the first part of the name of the compound. Cl, that's chloride ion. So we put chloride. So remember, magnesium, positive ion, name of the element, magnesium. Second ion, negative ion, it's chlorine element name. Keep the root, drop the ending ine, add IDE, and you get chloride ion. So the chloride ion is second. So magnesium chloride is the name of this substance here. Here we have Al2O3. So our two elements is aluminum and oxygen. So the first element is our positive ion. So since it's positive, it's going to be the name of the element, aluminum. So that's the aluminum ion. Followed by oxygen. Oxygen has a negative charge. It's second. It's going to have a -2. Not that it matters here, but it's the negative ion. So we name it according to the rules, according to the steps. So here, oxygen, we keep the root, drop the ending, add IDE, and we get oxide. So aluminum oxide is the name of that compound because we have the aluminum ion and we have the oxide ion, aluminum oxide. Now here it's a little bit trickier because here we have to recognize that this is a transition element. So when you're looking at compounds and in trying to figure out whether to name them, the first question you want to ask yourself Is it ionic or is it covalent or molecular, right? If it's ionic, then the second question you need to ask yourself is this metal a transition element or not? If it's a transition element, then more likely than not, you're going to need to use Roman numeral. So here, we have a transition element, so we're going to need a Roman numeral for the charge. Remember, the Roman numeral is always for the charge, not how many of the atom or ion you have in your compound. It's just for the charge. So we need to figure out what the charge is on the metal ion here. You can't really just look at this and say, oh, it's this charge. You have to figure it out. And you're going to start with the negative ion. You'll always know, or should always know, the charge on the negative ion. So here you start with oxygen. So oxygen, is in group 6. All the group 6 elements are going to have a -2 charge because they want to be like their closest noble gas. In this case, they want to gain 2 more electrons to have a full outer shell. They get that octet. That's why they have a -2 charge. So what we do here is we say, okay, well, oxygen here has a 2- charge on it. And for ionic compounds must be neutral. They must have no charge. Well, if the oxygen ion has a -2 charge on it, then that means that you must balance the charge with a +2. So there's got to be, since there's an overall 2- charge, then there's got to be a 2+ charge that's going to balance it. Well, since we have one manganese atom, then that manganese atom has to have the 2+ charge on it. So therefore, we have Mg2+. So since we have a 2+ charge, that means we must have a Roman numeral 2. So the name of this ion is manganese 2. Oxygen is an ion, so we drop the ending, add IDE, and that becomes oxide. So manganese 2 oxide is the name of this compound. Remember, the first ion is manganese 2. That's the name of that ion. The second ion is oxide. Put it together, manganese 2 oxide. And that's how you name your binary ionic compounds. For your compounds that have polyatomic ions, it's the same rule. Name of the cation plus the name of the anion. But in this case, the polyatomic ions, which are mostly negative ions, you don't need to change the ending. You just put the name of the polyatomic ion as it's written. So this is why it's really important to know the names and the charges and the formulas of your polyatomic ions so you can know what to write for the name. Okay, so here, for example, we have NaNO3. So you recognize first what the first element is, or what the first ion is. And so you can see here that sodium metal, aluminum metal are the first ones. So that's your positive ion. So most of the time, your positive ions are going to be metals, right? There is one exception, but I'll go over that in a moment. But you recognize, okay, my first ion is positive. That's usually going to be a metal. Identify that. And then whatever's left will tell you if you have a polyatomic ion or not. So here I have more than one element that is following the metal ion. So all of the rest of this has to be negative ion. So since I have more than one element, that tells me it's a polyatomic ion, and I should know the name of that ion. So NO3 has a minus charge on it. That's the nitrate ion. So the two names of the ions is sodium ion and nitrate ion. So this compound is sodium nitrate. So I put the two names together, sodium nitrate. Next, we have Al2SO43. Same thing. Recognize that the first ion is always the positive ion. It's a metal here. So Al is aluminum. So I write aluminum. That's for the aluminum ion. And then if I cover this up, you'll notice I have sulfur and oxygen left. that's more than one element. This is not a monatomic ion, it is a polyatomic ion. So SO4, I need to know the charge and the name of that. So you'll note SO4 has a 2 minus charge. That is your sulfate ion. So this is the sulfate ion, this is the aluminum ion. So aluminum is the first name, first ion, and then sulfate is the second ion, so that's the second name. So aluminum sulfate is the name of that compound. Now, it's not always the case that your first ion is going to be a metal ion. Most of the time, it's going to be that case, but sometimes it will be a polyatomic ion known as ammonium. Ammonium is one of the only polyatomic ions that are positive. So here I have NH4. So when you see NH4, you should recognize that as the ammonium ion with a plus charge. So here NH4 is first. If I cover that up, you'll notice that I have only Cl. So this is a monoatomic ion. So I'm going to name this like I do before with the other monoatomic ions here. So since chlorine is the name of this element, I'm going to drop the ending, add IDE, and that's the name of this. That's the second part of the name of this compound. So ammonium is the first part of the name, and then chloride is the second part. So ammonium chloride is the name of this substance. And then finally, you have CuSO4. So again, we have Cu for copper. Copper is the first ion. So we're going to name that with copper. But notice that it has a Roman numeral. Why? Because it's a transition element. So remember, when you have a metal, you want to first identify, is it a transition element or not? And then name it. If it is a transition element, you want to have a Roman numeral. There are exceptions. I'll go over the exceptions in a moment. But this is not one of those exceptions. So how do I find the charge on copper? Well, I first have to know what the charge on my polyatomic ion is. So remember, if I cover up the positive ion, whatever's left is my negative ion. You'll notice I have S and O. That's more than one element. So this is a polyatomic ion. So I need to know what the charge is on SO4. So that's something you just got to memorize. So SO4 is my sulfate ion. It has a 2 minus charge. That I only have one of these, so the total minus charge is a -2. That means that the total positive charge must be a +2 because the total charge of your ionic compound has to be 0. It's got a balanced charge. So your total negative charge should equal the total positive charge. So since my total negative charge is a 2 minus, then my total positive charge should be a 2 plus. I only have one copper atom here, so that 2 plus charge goes on to the copper 2. So that tells me that this is the copper 2 ion. So I have Roman numeral 2. So copper 2 sulfate is the name of that compound. Now, so let me recap again. So when you're naming your ionic compounds, you have to know the names of your ions. You take the names of the ions, you put them together. That is the name of your compound. And so for binary ionic compounds that have only 2 elements in the compound, first element is your positive ion, second element is your negative ion. You're just putting the names of the ions together. Remember, for the negative monoatomic ions, you have to drop the ending, add IDE. And so that becomes the second part of the name of your ionic compound. For the polyatomic ions, you don't have to drop the endings. You just need to memorize what the names of your polyatomic ions are. And then you can add that to the end. And also make sure you identify those ions, those positive ions, those metal ions that need a Roman numeral. And so the rule of thumb is that if you have a transition element as a metal, as your positive ion in your compound, then most likely you're going to need a Roman numeral. There are a few exceptions. Those exceptions are exceptions, right? Silver, cadmium, and zinc. So silver, cadmium, zinc are transition elements, but they do not have a Roman numeral because they only have these charges. So silver, by and large, only has a +1 charge. There is a +2 charge on silver. Can have a 2+ charge, but it's so rare that we don't bother to give silver plus a Roman numeral 1. It's just silver. Cadmium only has a 2+ charge. Zinc only has a 2+ charge. So there's no need for a Roman numeral for those metal ions. There are other ions that are main group that do need Roman numeral, even though they're not transition elements. That would be your lead and your tin. Lead and tin are main group elements in group 4A, but they need a Roman numeral because they can have multiple charges. So keep in mind that these are exceptions to the rule. Okay, and so that, ladies and gentlemen, is how you name, or how you get the name of an ionic compound from its formula. I hope this was helpful. If you liked the video, then please like the video, hit that like button, share the video with your friends. Make sure you subscribe to my channel, hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you want me to solve, or if you have a topic you want me to cover, then let me know down below so I can do that for you. I would love to do that for you. Thanks for joining me, and have a great day.